Hi, everyone. Look, I'm really sorry I can't be there in person. I've had a few personal things come up, and I'm really grateful to the Centre for Sustainable Healthcare for hosting this event. This is a very important piece of work. It's very near and dear to me. I'm the founder of the nitrous oxide project, which identified system loss and waste of anesthetic nitrous oxide to the magnitude of 80 to 100%. So I'm really glad that we're here talking about this particular molecule in terms of analgesia, and I think you'll really benefit from today's discussion. So why do we care so much about nitrous oxide? So it's 300 times more potent than carbon dioxide. It is an intergenerational pollutant. That means a baby born today may be long gone, and this molecule will still be wreaking havoc on the planet. But more importantly for midwifery, it's a really hazardous occupational health pollutant, and we really should be mindful of it. And I'd like us to be more mindful of it in terms of our working life. So how does it work as an occupational health pollutant, and what are the concerns with it? So nitrous oxide deactivates vitamin B12. That's its main function, and what that leads to is it then inhibits. B12 is a cofactor for methionine synthase to work. And anyway, through that cascade, you end up with, through that inhibition, you end up with B12 anemias. So I think that just gives you a sense of what it does. And again, Teresa will speak to this a little bit more in more detail. So it's quite important that we minimize it as an occupational health pollutant. As such, we manage it very closely. It is managed by COSH. It is we have very clear time-weighted exposures in the UK. We have very clear ventilation guidance, and you'll hear some talk about positioning and personal exposure monitoring, which I really want you to take on board. And I'm really hoping that you'll be empowered at the end of this to start having really challenging conversations with your states teams and ventilation specialists and medical physics and whoever you need to talk to about mitigating this molecule. So our emissions have steadfastly fallen, but this is Scotland, but you can still see the lower part of the graph accounts for analgesic nitrous oxide, piped analgesic nitrous oxide, and you can see that it makes up the lion's share of our emission footprint. It is improving in Scotland. We've started to mitigate our piped emissions of Entonox by around 11%, but there's still a lot more to do. To understand the issues around pipe systems, this is a variance graph, which I did for NHS England a few years ago. And if a system is working perfectly, on the vertical axis, you have your carbon emissions. On the x-axis, you have your maternities. If everything was working fine, you'd get a very tight line. So those dots would be close to the line, but that's not what you're getting here. And this shows system variance. And to an engineer, that signals systems that are under duress and not working properly. So a little bit more analysis. We have, this is again looking at the emissions intensity for the pipe per maternity. And for Scotland, that's sitting at around 385, this a few years ago, 385 kilos per maternity. It has come down. We know that based on some of the evidence you'll hear from Mark and Laura, that we think this should be closer to 160 kilos per maternity. So let's hear from them and then see what. So what we do know is that the drivers of system loss are associated with semi-permanent connections. So that's demand valves being left in, and certainly our Scottish midwives have noticed that to have an impact. Just removing them when they're not in need is really valuable. But also permanent joins, so area valve service units along the manifold. So joins anywhere along the supply system can be a point of loss. The other thing is also good management of your portable cylinders, something that we haven't focused on well enough, I think, in Scotland, but something that's really of value. Now, it's really important in all of this. In Scotland, we haven't supported any green tech specifically. We're quite tech agnostic. Our assessment of the central destruction unit that you'll hear a little bit about really didn't, the economic and environmental evaluation didn't really come through for that particular bit of kit. That's a central destruction unit produced by Medcare and supported by, I think it's Beacon Medeus. But we are still interested in catalytic cracking technology and are looking at tests of change with a company called eBreathe from Ireland, who are just producing a competitor to Medcare's portable units at 1/3 the price point. And we're also looking at Enviroleave, which is not using a catalytic cracking, but using a closed circuit system that will hopefully reduce the total consumption of nitrous oxide. So there's some exciting pieces of work, but it doesn't replace removing system loss and waste, because none of these technologies will address any loss along the pipeline. So it's really important that you get confident with having these conversations with your estate teams to look at mitigating system loss. Additionally, within Scotland, we're working on a new regimen for planned preventative maintenance. Michael Ralph, if he turns up, can speak to that. And that will influence not just Scottish protocol, but also UK-wide protocol through the Hospital Technical Memorandum. So that's me. Here you'll find the link to our Entonox briefing, and which I think is worth having a look. And we really want you to be confident in having these really difficult conversations at a state level, at a site level. Thank you for your time.